Okay, in this session here, I'm going to be discussing how you compute volumes using three different functions. So in this display on screen we've got a stockpile. This happens to be the perimeter of the stockpile, which is the base, and this happens to be the top of the stockpile. And as you can see on the levels there, that's 103.5. That goes down to about 100.7. Right? Variable levels around the base of the stockpile. So in this instance, the first thing we have to do is going to be creating a boundary, which is be the perimeter or the base of the actual stockpile. So you click on create boundary, and because this is a closed figure, all you have to do is snap on the lines, and then it will go right around and start to back to the finish again, and it's set as a boundary. So click OK. So that's now the boundary of the perimeter or the base of the actual stockpile. So what we have to do is we'll be creating two different DTMs, one encompassing the top of the stockpile and to the base, out to the boundary, and the other one we just base only. So what we have to do is go to our layer manager and turn off the TBL one, which is that top one, and just leave the base on. So now we're going to form a digital surface model of that. So we go to create DTM. We're going to be trimming it to the boundary, which is the boundary we just created. We go click OK, and we call this base. We go OK, and that's the base of the stockpile. Now, assuming the stockpile exists on an existing surface, so one can assume that it's a straight plane from one side to the other. We don't know if there's humps and hollows in between the boundary, so basically we just assume it's a one flat plane right across a grade. Okay, now we've got that surface done, so I'll just turn that DTM off, and now we're going to be forming a DTM or surface model with the other layer active. So we're going to be turning on the TBL one, which is the top of the stockpile, and forming another surface. So we go create DTM, and then we're going to be trimming to the boundary again, go OK, and we'll call this one stockpile. Okay, and now it's completed or created a DTM surface of the stockpile. So now we wanted to compute the volumes between the two. So if we click on surface, compute, the design surface is a stockpile, the natural or base surface will be the base. So we've got base there. The polygon boundary is the boundary we've just created, and we're going to be doing it by Prismodel and slices to compare the two different methods of actually computing volumes. Prismodel is the most accurate method. Slices is another one, but it's set at an interval of 0.5. You can use grid, but we'll find that Prismodel is the most commonly used one, and slices. So click OK after that, and I'll come up with a report. So the computation via Prisms method comes up with the surface area, design surface areas in there, and the volume in that particular instance is 76,978.53 cubic meters of fill required. Fill within fill within the actual stockpile. Using slices comes up with exactly the same sort of figure, 76,978.53. So that basically correlates with the Prismodel method using slices. So you click OK, that's all done. Close that report, which you can print out the report if need be. Okay, now the second method, we're going to be doing it by slices. So in this particular instance here, we've got a gully which we're going to be filling up to water. These levels around here, if I turn on my elevations, and the hot button there, the top of this banker is around about the 60 meters mark. So what we're going to do is fill that up to about 59 metres, so up to this middle area there, which is called Topo TBL. That's the name of the actual string or the line work that goes around there. So I'll turn off my elevations, and now we're going to be firstly now forming a boundary. Go to surface, create boundary. Again, you step on the line. It's a closed figure, and that's the name of the boundary we've generated in there. We go OK, and it's now formed a boundary around that middle or top of bank of this particular area. Now we're going to form a surface, create a surface from that. So we go create DTM, and it's going to be working on active what's already in there. Go OK, and we call this dam will do. Go OK. Let's form a dam surface around there. So turn off our mesh. Now what we're going to do is going to be again computing volumes. Go to compute, and we're going to be filling up the dam surface to make it 59 metres. We'll make it 59.5, for example. That's the dam level. That's the water level we want to fill up to. And what we're going to be doing is that is the DTM surface that we've got, which is called dam. That's the name of the job, which is listed there, ball 4. And we're going to be doing it by slices at half-metre intervals. Now we click OK. It comes up with a report. And the lowest level within that area there, within this area here, was 57.22. So what it does is, because we've set the interval at half-metre, it's brought it up to the nearest half-metre mark, which is 57.5, and every subsequent row after that is at half-metre intervals, 57.5, 58, etc. Up to 59.5, and the cumulative fill is 50,058 cubic metres. So as shown on there, the total volume is 50,058 cubic metres of water, or volume of whatever it is, filling up to that RL. So that's the computations via slice method. Right, in this last session for volumes, we've got 5 different stockpiles, individual stockpiles. So what we're going to do is initially create a boundary for those stockpiles. So we go to surface again, click on surface on the menu bar. Instead of creating individual boundaries like we did on the previous 2 options, or 2 different functions, what we do is go to create list. So firstly, I'm going to turn off these layers here, which are the top of the stockpile, so we're just leaving the base. So we go to our layer manager, turn off both those layers there, so all we're left with on screen is the base. So what we do to create a boundary, we click this option here called create list. So click on create list, comes up with boundary name, boundary list 1, and now click OK. And what it's got is the 5 different boundaries as listed in there. You can actually have these boundaries or these coded names around there and lines with individual names depicting the actual stockpiles. Could be sand, rocks, rubble, whatever. So therefore then it becomes individual to easily spot which volume is which. Okay, so now we've created our list, and now we're going to go to our layer manager, turn back on those other surfaces there. Well, actually, no, hang on a sec, I'll just keep those off. And what we're going to do is form a boundary base surface. So we go to surface, create DTM, based on the active DTM that's in there, no boundary required, go OK. We'll call this base, go OK. And that's the base surface done. Turn that DTM off, go to the DTM manager, turn off mesh. So that's now off, and now we'll turn on our other layers that we had turned off, which is the top of the stockpiles. and form another surface. So we go create DTM again, work on the active layers, go OK, and we call this stockpiles. Okay, and now the DTM is formed, including the top of the stockpiles. Right, now we've got those two surfaces. So now we go to surface, and this time we pick batch volumes. Click on batch. We're going to be calculating the surface one will be the stockpiles. Job is called vol9. The surface reference will be the base, and the boundary list is called boundary list 01. Then you click OK. So that's we're calculating. The surface one is the stockpiles itself. That's the job we're in. The base surface or reference surface is the base, and that's the boundary list. Click on OK. And now we've got our volumes displayed in here for the fill volumes. And what it's got is the volumes of each one of the surfaces in there displayed on screen. Click OK. Close that report. And that's basically done. Now it's computed all the volumes between the base surface and the top of the stockpiles. All those are all done in one hit. That's the easy way of actually doing the batch volumes, by creating a list. Okay, that's the end of the session. Okay, just one other method I'll show you quickly is an option there called quick volumes. So I've gone back to my first job, which happens to be the stockpile. There's no DTMs formed whatsoever. So what we're going to do is go to quick volumes, which is in the list over there. You don't have to form a DTM beforehand. So basically the selection will be active, what's on screen. There's an existing boundary already there, or you can create it automatically by using one of these methods here, by selecting that and go type boundary. But in this instance here, we've got a boundary created. And the base we're going to be creating automatically. So all we have to do is click on OK. And it's now created a volume report with 76,978.53 cubic meters of fill, which is exactly the same as what we had before. And what it's done is created two new DTMs. So I'll just expand this out a bit. One being the base, and one being the stockpile. So it's automatically done those two just on the fly. So it's basically a nice and simple method of actually forming a DTM just by using that quick method and doing quick volumes. Okay.